let's start. Isn't it so tired? Like last day and then afternoon lunch, right? Suddenly so sleepy. So, okay, so this is our Google Drive and then program 3. So we download some file and then we have a slide. So I think all of you already can access this one. And then here is several HTML file, which actually we have all the solution for what we did so far. So for example, 1 is day 1, this 2 is day 2, and then this one is day 3. So if I click, this is just HTML file. So if you just click it, actually it shows like this way. So what we have to do, click this, and then you have to download it first. Download it, and then if you open it, there's all what we did. Not exactly same, but all the contents and explanation is available there. Just to show how you can review all other stuff. So I will download this one today. Alright, then let's go back to our art practice part. So this is the art studio where we started. So before we move on to the next step, I want to show how we can save this plot. The reason why we draw this plot is we want to show this on something else, right? We want to use this one for your figure, for your manuscript, or want to share this other visualization to other people, right? So here, if you see here, there are export, and then there are options: save as image or save as PDF, right? So if you click save as image, you can set up the file name and you can change the format as what you want here. So let's save as this one PNG file, and then I will make this one is mean 95 percentile CI, and then you can also change the size and everything, and then click save. I click the save. Then if you click this file under your working directory, I think it's for here R-info1 is our working directory in my case, and then you can see now mean 95 CI PNG file is there, right? So if I click this, yes, we have this one. Okay, the same as you can do same thing as with the PDF format, or if you want to write, just PDF P5 file name equal mean 95 CI.pdf and run. I see something wrong here, so let's run this one again. P5 run. Oh, I see. So, okay, I see. So in this case, I need to open the PDF first. And print P5. Okay, so let's run. this PDF. That means I will try to make a PDF file. Just try to open this file, and then over there, print P5 plot, and then let's close it. Okay. Then if we go back to our file folder, now I can see here my PDF. So I think here is Adobe is something problem, so I will close it. But you should have some PDF file. Okay. Then let's go to our testing part. So now we can do the testing. So today I will show how we can do the two sample t-test, the most simplest one, right? So here I will say we are gonna do two sample t-test. So if let's remind ourselves, we have the data called one protein, which include all intensity across the 12 ms run for one specific protein, right? So if we remind ourselves, here is this one protein look like. And then we want to do the t-test. For t-test, we can compare only two groups, two conditions. However, one protein data, we have four different conditions, right? So let's get some subset of two different conditions from one protein. Okay, so I will say one protein 2 should be one protein and one protein condition. That means include condition 1 or condition 2. Okay. So again, that means I want to get some data from one protein which has condition 1 or condition 2 in condition column. Okay? So if you go back to this environment, originally the one protein data have a 12 observation for 4 different conditions, and then condition protein 2 have only 6 observations. Okay, so let's check how it looks like. So I will click this one protein 2. Okay, here we go. We have only 6 rows, which have only condition 1 and condition 2. So now we can compare these two conditions. Then for t-test, there is a simple function for t-test in R called t-test. So here that is important. The t.test is the function name. So let's check what is t-test doing. So I will run, and then it shows what kind of things we can do this. So for example, here t-test needs some data,
And then there are several options. The reason why I just explained this one is, t-test is one of the functions. And then this is not universal, right? So based on your data, you probably will get some different functions, right? And then nobody can remember all the functions, what kind of option they have, right? So always need to double check what kind of option or what kind of flexibility you can have from these functions. So for t-test case, here alternative means what alternative the hypothesis you can use. So you can choose two-sized hypothesis or less than your alternative hypothesis or greater than alternative hypothesis, right? So based on which your alternative hypothesis you use, actually the p-value definitely will be different, right? And then also mu means if you have only one sample test, you have to assign the mu. You want to compare 0 or you want to compare that value equals some other values. Or you also can assign you want to have a t-test for paired or not paired, or you want to use the equal variation assumption or not, and so on. And also you can automatically can calculate the confidence level, confidence intervals with the 95% or 90% or 99% and so on. So this is what the t-test function is provide to you.
Then let's try to some very simple things. So I just want to compare between two conditions, condition at 1. So I want to compare log 2 intensity between condition from which data? 1 protein 2 data, which include only 2 condition information. Okay. Then if you run, here is the result, right? So output is not just data or something. It looks something different, right? Not the table or not vector or something. So it shows several information about the result.
So it says we do the 2 sample t-test. What kind of the data we use? We are going to compare log 2 intensity by condition. And then here is a statistic value. And then here's the degree of freedom. And then here's the p-value. So p-value 0.0120. If you have a 0.05%, this is not significant. And this is based on what kind of alternative hypothesis we use. You can see true difference in measurement is not equal to 0. And then here's a 95% confidence interval. So here's the things. And then it also shows the sample estimation between these two. So basically they compare these two. And then based on this, here's the t-type of statistic. And then this is the final p-value.
So we can get this result, right? However, I want to save this one another data, right? So here I will call, I want to save here in here. I want to save this result in the data called result. Okay? So then if I run this line, nothing show up. Nothing show up here. However, if I select this result and run, and then result have all this information. So basically, result saved all the our testing result. Okay, so far? Then I will ask you some small challenging. let's do the t-test again, but I want to calculate 90% of confidence interval for our four changes between condition 1 and 2. So basically, we want to do the same t-test, but just want to change the confidence interval level, right? So I will just double check t-test help file again. And then if I go back to here, there are several options. If we did not define any parameter, they always use the default parameters. So here you can see confidence level is always 95%. This is default. Then if you want to change this, just 90%, I will just add this comment in our the testing. So what I do, I will just copy here and then paste, and then this is another result. However, I will add here, I want confidence level equal to 9. Then run, and then I just double check again, and then now it changed here. This is 90% confidence level. Okay. Okay. Then, okay, here they record all the results in the screen, right? But what I want is I want to extract exactly this value separately, and then save somewhere else. I don't want to read this one again and again and again. And especially if you have multiple proteins and then we want to test for each protein, and then we cannot see every proteins. We cannot manually see this one and then just check the p-value and so on. This is impossible, right? So we want to extract the value from this test. So the result have what we say here, it looks completely different. But how we can extract? So to see how they call each element saved, we can use names function here. Then if you run, it shows here what kind of the value they saved in sample. So basically this result have this 1, 2, 3, 4, 9 different information, and then just report as this text. So which means we can extract each value, which means we can extract p-value separately, we can extract confidence interval separately, what kind of alternative we use separately. So let's see, for example, how we can extract. In this case, we use the $sign, like the column. So here, result, p-value, it shows 0.12. So which is here the same p-value. We can extract these numbers. And also we can extract confidence interval information, result, confidence int, and then run, and then report the lower and then upper bound of the intervals. Okay. Then I will give you another task. Now we can see here our the result is not significant. Then I will give you the short task again. Then let's compare between condition 1 and condition 4. And then calculate p-value and 95 percentile confidence interval for change. If you finish, please put the blue one. If not, please put the red one if you have issues. For change of intensity. Yeah, for change of, okay. Yeah, for one protein, we have only log intensity column, which only, that column is only numeric value. So we can only calculate that numeric value. So, I think many people done. So, what we have to do, first, we want to get some subset of the data, include the condition 1 and condition 4, right? That one too. So our code just temp is from one protein, and one protein condition information include. So this is not type 1, this is include, so a little bit different. And it should include the condition 1 and condition 4. And don't forget comma, which said I want to extract the row, include these two informations. So let's run this. Then now temp have a 6. And let's double check. So now they have a condition 1 and condition 4 here. Then I want to do a t-test for log 2 intensity between condition from data temp. And that's it, because we have a 95 percentile confidence interval as a default. So actually we don't need to define it. So here, if I run it, now here is our values. So now we can see now p-value is quite small. They say it's quite different, right? So I saw we can extract this p-value, we can extract this t-value, and how we can calculate the difference between this log intensity. Basically, how we can calculate the 4 changes of log intensity is actually they report these 2 estimation, or actually not report the 4 change itself. Then we can actually calculate it. So let's look at let's say this is result 3. Just let's save it in the result 3, and then just check names of result 3. And then here we have estimate information. This includes the mean value between conditions. So result 3 estimation, it shows 2 value, but actually we can calculate their difference. How? Bracket 1. Bracket 1 show the first value. Bracket 2 show the second value here. So basically we can manually calculate result 3, estimate 1 minus result 3, estimate 2. Then it said their forward change is 5.265 and so on. Okay? Okay? Then I want to save this 2 t-test result as just one simple table. Okay? So let's do let's try to do this. So to make this table, let's make a table first, just empty cell, but let's make a very small table first. What I can do, temporary data, which include the matrix with 0 value, and then n row is 2, and then n row and column equals 3. Then let's just see what is the temp look like. Like this matrix. So which I said I will put all 0, but let's make a row, 2 rows, and then 3 columns. So my plan is so for each row I want to save the result. This one should be condition 1 versus condition 2. This one should be condition 1 versus condition 4. And here is the forward change. And then here's the t statistics. And then here should be the p-value. I will put this. And then if you can save this later, we don't need to do the t-test anymore. So let's see. Temp 1. If I say this is first row and then all columns, right? So basically means here, and then we have a 3 space, right? Then for this space, I will put, let's make a 3 space. I will put some value here, I'll put another value here, I'll put another value here. Okay? Let's just try to test it, like just 1, 1, 1, and then how it will be. Yeah? Then let's see how TMP look like. Like this, right? So first row, 3 space, I want to put 1, 1, 1, and then it will become like this one, right? And then let's change this one for our test values. So first one is result 1. Okay, let's go back to the last point. The last one, I want to put the p-value here. So p-value, how I can get result p-value, right? Let's put the p-value at the 3rd column, and then 2nd column, I want to put the result t-test statistics, right? And the first one, I want to put the 4 changes. So 4 changes, as we did, we actually need to calculate manually. So from result, And I just run, and then let's double check how the TMP look like. So now the first row of TMP have our test result over there. Okay. Then let's do the small things again. Please put the all information into the second column with the from result 3. Okay. Okay, so it should be same as before, but what we need to change is from which data, the which result. So the result 3 is for condition 1 versus condition 4. So I just changed here this result and then run, and our temp now have all new values here, right? However, okay, what should be the next step? Yes? Yes, column and rows too, right? So we need to put the information here. So first, what I will do is still the temp is have a little bit different type. So if I check the temp, it is a matrix, because when I set up this data, we actually set up that this is a matrix, right? So first I will change this one is as a data frame, and run, and then I will just double check TMP again, right? So same information but a little bit look different, right? Then what I can do, I will change the column name first. How I can change the column name? First, call column name, and let's see what column name now. Here, as you can see, here's the column name is X1, X2, X3. Like we have a 3 spot we can replace it, right? Then what we can do, okay, column name, let's put some other information into the column name. How? Just make a vector, and then we have a 3 space, right? Make a 3 space first, and then first one is log to 4 change. Second one is statistic. Here is T statistic. Let's remove the just 0. And then last one is the p-value. And let's double check how the TMP look like now. Now we can see the column name is changed, right? And then also we need to change the row, because we need to know this one is from which comparison. So here, row names, TMP. Now row names of the TMP is just as you see, 1 and 2. And then I want to put some other information into row names, our comparison name. So that we have a 2 space, right? We have a 1 and 2 information can put it. And the first one is for compare condition 1 versus 2. And second one is condition 1 versus 4. Then run, and now okay, I will make this one here. Now this is our TMP, right?
So here we have information which comparisonly compare and then log changes and t-test and t-value, right? If you have more, absolutely more, and then if you have a more protein, you can also label it by each proteins, and then you can save this, and then you can just record this one, or you can use this information for your plotting too. It will be the last one. For example, you can use this p-value. So most common one is kind of volcano plot. You know, yes.
What is finding what you want that you use data frame to
This one is, okay, so previously here we make a, I will go back. When I make a TMP for the first time, I assign this metric, this data should be metrics, but now I want to convert data frame type. Right? Yes.
So following up on that, you had said data frame instead of matrix the first time. You wouldn't have to do that?
Why did you make the matrix and not a data frame here?
So here I just make this matrix because in the matrix we can always contain the one type of input. Like for example, all have to be numeric, all have to be character, right? The data frame we can have a different characteristic for each column, right? So like one column can be like numeric, the one is character, and so on. So for data frame, like for first region is easy to make it. Like we can just assign number of the column and number of the row. It's very easy, and then we're gonna put the numeric anyway. So that's why I just made it like this way. However, if you have some different data, actually we can start with the data frame too. Is it okay so far? Okay. So this is the one type of the testing, but what I want to before I move the other one, I want to address some other aspect. So here is the from our HTML file. So I don't need to show all different type of analysis available, but I want to mention that depending on your data, the statistical method should be different. So today, what we are working on the data is IPRD, which include log to intensity by column. So mainly we compare log intensity column by condition, right? So we always use log intensity and condition when we plot, when we calculate, and so on, right? So if you remember what we are doing here, so here, if you look at here, t-test, we use log to intensity and the condition, right? So we actually use these two value. However, so this is a numeric value, but this is not numeric value. Right? This is kind of categorical value. Or we can say this is quantitative value, or this is not, right? But this is one type of the data. However, sometimes we can have this is kind of another condition. And this one, we can actually switch it. For example, based on log to intensity, if you want to predict our condition, right? If you have a complete different aspect, y and x, location should be different. Not only location, actually all the methods should be different, right? Or sometimes we have also another aspect. It can be just count data, means if you have two different type of the conditions. Maybe this is just gender, and this is just can be the condition, and not this numeric. If we have a numeric but just count data, in all different cases, we actually try to use some different way. So t-test, we always just think about the t-test or ANOVA. However, that is only for this type of the case. Okay, so today, 2.5 days is not enough to cover all things, from start to R. So we just show one of the most popular case. However, if you're interested to some other data type, you have to think about different functions and then what kind of option you have to use it. So that's why I just want to keep showing the help file. Just if you want to do something else, find the function and then just check all the flexibility, and then you can try to make this make works. Okay. Then let's move on to the sample size calculation. Actually, I finished quite a lot while I prepare for this section though. Do you want to practice some other cases, or you want to move to the sample size calculation? Yeah.
So when we filter for particular conditions, if we don't put a comma towards the end, it doesn't give an error, but it doesn't filter also. So how is R interpreting that as? So if we scroll up, then we are filtering for the conditions in 1 protein.
Condition for one protein. So very up.
130, then
130.
no, scroll down.
Go down. No, it's fine.
Yeah, here. So if you don't put the comma towards the end, there's no error, but there's no filtering also.
Okay, let's try. So I will just copy, and then I will here, and then he remove this, and then let's make this one is just another one, right? Okay. Here. In my case, I have an error message. Let's try to make. Oh, okay. Here I remove this. Okay, let's try to this. Okay. Then here, right? The open. Right. Well, I'm not 100% sure. So, I'm not 100% sure why they are not make error message. But it seems like this is something not working, so they just report just original one or something like this. But I'm not sure why. Does any TA have idea why exactly happened?
I think it's just because it doesn't know whether it's a selection condition for amount or rows, so it's just select all the columns.
But it's just one column, right? It's the condition column. So it should know.
But no, actually, because if we don't have comma, actually they probably can search condition row 2 because they don't know which that is condition. What is this came from?
But we are telling you to slice one column in the first part and then select your 2 rows.
So if you don't put a comma, if you put a comma, it's asking you to search each row in the same percent. So for each row, you can search. And you don't put a comma, you don't really use it. So how does that search? How does that really return true? That's why.
Because I also found I just put the comma here, and then it showed all the columns. Or okay, maybe it makes sense. Okay, let's try to this one. Only this one. This one is just it should show the true false value, right? So let's see. That's true, false, choose for, right? So here we have a true, 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 6 true, and then other false. So they got first 6 column, and then there's but we already have only 6 variables. So that's why it looks like we call the copy the original one, I think.
So does it return a vector or
It's a table because here we just comma here, and then actually they just select the first 6 column here because it says we have a true.
so one is common and one is common?
So let's go back to, I see, okay, here let's see, original one we have a 7 variable here. Now this one we have a 6 column. So definitely if we put the comma here, we just use, call the first 6 columns. Right. If we didn't put the comma, yes, I'm not sure. This is still have a 6. No, let's try to this. Without the comma, let's run here. I think if we don't have comma, they just recognize this is just column calculation, or because we assign the condition, they just recognize the column first. Yeah, they need to decide it should be the row or it should be column. I think. Yeah.
So it doesn't record any vectors.
I mean, but here is, if you put the comma here, that is missing, but here we don't have any, true for, how they define the only column. Yeah, I think here they just, look at the only column first.
Yeah, that's really
Okay, so let's try to find the solution later. And then do you have any other questions? Or do you want to press something else for this testing? Or do you want to move on to the sample size? So sample size, blue, practice something else, red, sticker please. No preference, no answer. Move on to the sample size. Okay. Okay, so then let's try to calculate the sample size. So the lecture at 11, she showed some formula, right? To calculate the sample size, we need to know how much variation we have, how much desire for change we have, how much power do you want, and so on. So we have some formula. So if you just a little bit rearrange this equation, actually we can calculate it. However, there's a package which actually can calculate our sample size. Let's call the package PRW. I think this came from power. To calculate the sample size, yes? So we actually need to set up several things. First, we need to say what significance level you want. That is called alpha. And we need to say how much power do you want. And we need to define what is your anticipate for change. And then what is your anticipate variability. So basically variation. So for this, actually, we need to give them in the functions. So let's say this is alpha. We say this is I want 5%, and then I want power is 95%. I want delta 1.5 for change. I assumed our variation is 0.9. So this, yes.
Is that regular change or is log change?
It's depending on your case. Depending on your case. So if you want, if that is should be actually linked to the sigma value. So if this sigma value is intensity scale, this one also have to be intensity. Sigma is log 2 scale. This is also log 2 scale. So let's assign this for value. Then we need to, one more thing, calculate it. We call D should be delta divided by sigma. Then our power, the sample size calculation function is ready. So the call this T-test D should be equal to D, significant levels equal alpha, power equal power, and then what kind of t-test you use, type equal to sample. Which means I want to use two sample t-test power calculation, and then this D is what we define here. This is also what I define, and then for this t-test we want to two-side test. Then this N is our sample size. And then here they wanted this N is number of the sample for each group. Okay? So which means if you want this significance level and with this power for two sample tests with the 0.9 variation, you need at least 10.4 sample, which would be 11 per group. Okay? And then probably you already noticed that when actually I start to, power that, actually it shows a lot of multiple different functions, right? Here when we use this is, I'm gonna use a t-test, right? But your goal is to use, like for example, ANOVA, or to proportion comparison or chi-square test for different tests. They're going to calculate the different power or sample size. Okay? So depending on what kind of the testing strategy you use, you have to use the different functions. Okay? Then, okay. So we actually practice how to use the help file, and then this is how we can calculate the power and t-test, and then I will give you the short text. Let's calculate the power, not sample size. Let's calculate the power with 10 sample and the same parameter as above. how we can calculate the power instead of the sample size. If you have answer, please put the blue one. If not, please put the red one. Okay, so let's try to do this. So how we can calculate the power? So what commonly I do is always just searching what is this function provide. So here,
Here's the information. So previously I put this number and put this number and put this number, and then I set the power, right? If you know here, we can see there are 3 lower value, which means we have to provide the other 2. Then they're gonna calculate something with the null, right? So if you want to calculate the power, it should be null. Otherwise, other value we have to provide. So to calculate the power, give them n value, and then give them d value, and then they're gonna calculate the powers.
so from here, I will just copy this, but I will just make this power null, and I will give the n equal 10. Then now it calculates the powers. Here, n equal 10 is these what we provide, and then now we have a different power. So here in this case, probably the 94%. Yes.
So you can leave out too, right?
Sorry?
You can leave out power equals null.
Yeah, or we can rebuild it. Yeah, then if you did not give any value, actually they always use the default one from the help.
Delta would be based on some pilot study.
So pilot study, okay, so here's the thing. So yes, the same question I got. So how we know these values, 4 values, right? So sigma and alpha, I think this is quite obvious. We can change this. Then how we can find this one, right? How we can find, how we know this variance, how we know that this delta. I think delta is also a little bit easier, like how much for change you expect is you can define. You want find 1.54 change, or you want to find a 2.4 change, and so on. But sigma is really difficult, right? So if you already have a pilot study, you can have some estimate variance from your pilot study, and then you can assume our next study will have a similar variation. Or if you don't have any information, you can use just literature review and provide some variance for their study, and then we assume ours should be similar as that one. Okay? And then another next question is, we have a multiple protein, like thousands of proteins, and then all the proteins have a different variance, right? So what kind of the variance we have to use? You can use the median or most frequent variance, which is kind of the most frequent value. Or if you want to be more conservative, use the maximum, probably give you the really large number of the sample required, but that is a safe way if you prefer. So it's really depending on your decision. So that's why this calculation, to know, is it up to you. You have to define to me, and then I will calculate some numbers. Okay? So I will show you something, a little bit complicated code one. You don't need to follow everything, but I will try to explain what's going on here. So it's already there. What I want to do is, so this is, we can calculate the one sample size and one powers. However, I want to calculate some different cases, some different combination, right? I want 4 changes range 1 to 4, right? And then how will be the sample size will be different. And if we have a little bit range of the variance, and then I want to calculate it, how it look like, right? So I tried to think about how easy it is, but I couldn't find it. So it's a little bit longer, but I will try to explain to you. So first line is, I want to test delta, 3 different delta values. So 3 different 4 change values. And then I just calculate how many the delta you want to test it. And then here sigma also, I want to test 3 different variations. So very small variation and then large variation. And then I just set up 3 by 3. So basically 9 different combinations I want to calculate it. So I will run this.
Why is sigma is 0.1, 0.5, and 0.1?
0.1 and 0.1 is actually safe.
Right.
Yeah.
You said in very small to very large.
Sorry, maybe. Yeah.
Okay.
Yes, this makes sense, right? Yeah. And this one too, right? Yeah. So let's try to run this, right? Then what I do next is, as what we did before, I will make the matrix because I want to save our final n value for each combination, right? So 3 by 3, right? 3 by 3, and this is 3 by 3, and then just here. So here, sample size. So I just make a matrix with all 0 value here. And how it look like? Why is it look like? I see, got it. Got it. Okay, I confused. This is sequence, not C. Okay, I will go back. Sorry. Okay, I fix my what I said. Here should be point 1. This is not C. This is sequence. Means they're gonna make a sequence from here to here by point 1. Okay. Yeah. So let's run this one again. Let's do step by step. So let's run here, and then how the delta look like. Delta has 0.1, 0.2, 0.3, and so on, 0.0 to 0.7. Okay, so now that's 3 by 3, so 7. And then here, ND, calculate how many different delta you want to calculate. So now 7 different delta, right? And also this sigma also same, 0.1 to 0.5, and then separate by, their width is 0.1. And run, and then sigma should be 0.1, 0.2, 0.3, and up to 0.5. Right? And then this length should be 5, right? Should be 5. So 7, 5, and then we are compare like 35 different cases, right? So here we go. So I just run, and let's check this one again. So now we have a 35 and then 3 columns. Let's see what we can do. And then here is just let's fix the counter one here. And then here the 4. So 4 means it's a grouping. So we have a 7 different delta and then 5 different sigma. So how I will do is first fix the 1 delta, and then with the first delta, we are going to repeat the 5 different sigma, right? So here, first one, what I'm going to do is just choose the first delta. And after that, I will select first sigma and then calculate the t-test, right? This is the same function what we have. And then extract their information and then put it here. So the same side is this one, and then we have 3 columns, right? So first column from here, we are gonna put the delta because we know what delta value we have to use, right? Second column, we put the sigma, which sigma we use, and then here, finally, sample size. And then ceiling means what is the occurrence, like the round occurrence, right? So then if you repeat it and 30 times, 5 times, based on each combination, we can calculate this sample size, right? So normally you don't need to, but you can do it just if you want to test several different cases. You don't need to type it, but I will run, and then it's not take too long, just very shortly they are going to calculate it here. And let's check the how it look like. So they have all values here, but it's a lot ugly, right? But I think now we don't have this row value, row names, but we need to define what is this. This one should be delta, this one should be sigma, and this is the sample size. So I just assigned a column name here as what we practiced before, right? Just column name, and then we want to replace this column name, right? And then if I go back to our head of sample size table, now we can see this one, right? We can read, manually. However, maybe easy to draw something, right? If you make some plot, it will be easy to see how it look like. So I will go back to our ggplot one. So first what we did, like we set this data as a matrix. So I want to convert this to the data frame to make easy to draw for the ggplot. So sample size as data. Oh, maybe I can just use our reference one. So first, I make this is data frame, and then this variability column means variance 1, but now this is numeric value because we put the numeric value, but I changed this is vector, means they think the variable value 1.1, 0.2, 0.3 up to 0.5, even though it looks like numeric, we actually make this is grouping. So for plotting, let's see the sigma value equal one group, how it look like. Let's see the second group, how it look like, and so on. So let's run these 2 lines, and then data itself looks just same as before. But we can draw the plot. ggplot like here. So we use this sample size data, and then x-axis should be our delta value, and then y-axis should be our sample size calculation, and then we are grouping by our sigma. And then let's try to run this one. And then because we never say anything at all, so in the plot itself, it will be just empty. Just place the frame first, and then it said we are gonna draw the line. Let's see how it look like. Just line, based on our variability. So we can see different line here. And after that, we are gonna add some point because it's not easy to read actually where is our calculation. So here, run, and then actually they point out actual our calculated value for each desired for changes. And then we can do some different labeling. So other one is just labeling one, so you can change as much as you want. But here is our result. So here's our anticipated global changes in the variability. And then the red one is a small one, and then purple one is the largest signal, right? And then here's the large. And which means here the purple one always have a more sample size reading. Which means if you have a more variation, if you want to guarantee the same power and same significant level, we need a more number of sample size, right? And here means this of course this axis means if you want large fold changes, we actually need a small sample size, which means large fold changes is kind of easy to guarantee there are really big differences. However, if you want to check the very small fold changes, and with the very, even these small changes will be significant, actually we need more number of the sample size. So here, if you go down, you can see we need more sample size. Okay? So I think we are okay and ready to afternoon refreshment, and then let's come back at 3:30.